Okay, pre-cal students, in this video we will be, excuse me, I'm on the wrong page here. We will be studying the set of trig identities called power reducing identities. Power reducing identities. So your heading today is obviously power reducing identities, lesson 10.5, and be sure and include today's date, okay? Be sure and include today's date. Power reducing identities, lesson 10.5, and be sure and include today's date. Now let's continue on. Here are the power reducing identities right here. And you do not need to turn your books if you don't want to, but if you would like to turn your books, you will find these identities on page 659, okay? And look what they do for you. They basically, well, not basically, they definitely take a trig function that has a power of 2, and they rewrite it so that we do not have a power of 2. That's why it's called a power reducing or a power eliminating function or formula, okay? So what it does do is it takes a power, a sine squared or a cosine squared or a tangent squared, and it rewrites it so that you have a multiple angle, a 2u, a 2u, a 2u, and a 2u, okay? So with all of that in mind, we're going to use these today in one quick example. We're going to take a look at one example that will help us better understand these identities, okay? So with that in mind, here we go. Okay, we're going to rewrite sine to the fourth power as a sum of first powers of the cosine of multiple angles. That sounds really confusing, but listen to me and I'll explain it really, really well, okay? First of all, we're going to rewrite sine to the fourth power, sine of x to the fourth power as a sum. So we know we're going to be adding or subtracting different terms, okay? Secondly, all of those terms will be first power cosine. So we'll have a cosine here, power of 1. Like here, this sine has a power of 4. Okay, all of our expressions are going to be cosines with the power of 1, okay? And then your angle will be multiple angles. So you won't have an x here. You might have a 2x, or you might have a 3x, plus cosine of 4x, etc. Okay, that's what we're going to do. We're going to split this up into a bunch of cosines of one power and multiple angles. Okay, so here we go. Now, obviously, we're going to use our power reducing functions. Okay, and we have sine to the fourth power, and nowhere on your power reducing formula identities do you have a sine to the fourth power. So we're going to rewrite this as sine squared times sine squared, okay? And then for sine squared, we can make the substitution right here. If you look at your power reducing identities, we can put 1 minus cosine of 2u over 2, and then times 1 minus cosine 2u over 2, okay? And now if you take the top, remember you have a binomial times a binomial, so you have 1 times 1, 1 times cosine, cosine times 1, cosine times cosine. If you do all of that work, I'm not going to show you all the work because that's pretty much algebra, but you would get this. You would get 1 minus 2 cosine of 2u. That'd be an x, wouldn't it? Sorry about that, students. 2x, because you started off with an x, not a u. So 1 minus 2 cosine of 2x plus cosine squared of 2x, okay? And all of that would be over 2 times 2, which is 4. Now, I really don't want a big fraction like this, so I'm going to do something a little unique here. I'm going to go ahead and pull out a fraction. And what I mean by that, students, is this. Watch this carefully. I can put 1/4 and then put a parentheses and then put 1 minus 2 cosine of 2x plus cosine squared of 2x. Let me show you why I could do that. Watch carefully. If I were to put this whole thing over 1 and then multiply this 1/4 back through, I would get this right here exactly. Would I not? Sure I would. You would have 1 times the whole top, okay, which is just the top, and then 4 times 1, which is just 4, okay? So all of that there would definitely make sense. Now, what I can do is, let me get rid of this fraction. Now, my goal is almost accomplished here. What I'm trying to do, remember, is write all of my cosines with the power of 1. So this is the only thing I need to get rid of right here. So I'm going to put 1 minus 2 cosine of 2x plus, and now for cosine squared, I'm going to use my power reducing. I'm going to put this, be careful though, notice your u is a 2x. Okay, your u is a 2x. So in the identity, we have cosine squared of u is 1 plus cosine 2u. So you always take 2 and you multiply it times u. Do you see that okay? Well, notice our u is a 2x. So when I make the substitution, it's going to be 1 plus cosine, and it would be 2 times u, and u is 2x. So 2 times 2x would be 4x all over 2. Okay? There we go. And of course, all of this still has a 1/4 on the outside. Now we got to quickly finish this, okay? So watch what I do next, okay? I'm going to bring down my 1/4, and now inside here, I'm going to put this. 1 minus 2 cosine of 2x plus, and I'm going to pull out, now watch this carefully, a 1/2 here. 1/2 times it would be 1/2 times 1 plus cosine 4x. Now if you're confused on where that came from, just watch carefully, okay? See this expression right here, guys? Look up here and watch this carefully, okay? With this expression right here is the same thing as 1/2 plus cosine of 4x over 2. I took it and split up into two terms. If I put these two back together, I would have 1 plus cosine of 4x all over 2. The exact same thing. So I split this up into two terms, then I factored out a 1/2. So pull the 1/2 here, and you're left with 1. 1/2 times 1 is 1/2, and 1/2 times this would be cosine 4x over 2. Okay? So I factored out a 1/2. Now, in the back of the book, really, to be honest with you, you've done everything they've asked you to do, okay, totally and completely. But for your answers to be simplified so they match the back of the book so you know what you're doing, so you can check your answers and make sure you're correct, let me show you a couple more things you could quickly do, okay? First of all, we can do this. We can take the 1/4. We could multiply the 1/2 back through, and we're left with 1 minus 2 cosine of 2x plus 1/2 plus, now watch this, 1/2 cosine of 4x. That's a little better, okay? Then take your 1/4 and multiply it through, and you're left with 1/4 minus 1/2 cosine of 2x plus 1/8 plus 1/8 cosine of 4x. What I did is I took 1/4 and I multiplied it times each term. Okay? Hold on 1 second. This is one term right here. So times this, times this, times this, times this. I got this. Okay, now in the end, if you wanted to, you could factor out a 1/8. And why 1/8? Well, 1/8 is your biggest denominator, okay? And if you factor out a 1/8, after you've combined like terms, here's a like term, here's a like term, here's a like term. After you combine all of those and then factor out a 1/8, you would be left with 3 and then minus 4 cosine of 2x plus cosine of 4x. Now if you're a little confused there, watch this carefully, okay? 1/8 times 4 is 1/2. Okay, and 1/8 times cosine to the 4x is 1/8 cosine to the 4th. And where does 3 come from? Well, guys, if you add 1/4 plus 1/8 plus 1/8, let's see, you would get 3, 4, on the, let's see here, you would get the 3/8, I believe, which would then, you pull out the 1/8 and you're left with a 3. Well, you would not add the 1/8 because the 1/8 is being multiplied times the cosine. So you would combine 1/4 and 1/8. And when you combine those two like terms, you get 3/8. and then factor out the 1/8, and you're left with a 3. I'm really okay with this as your answer here, as long as you take your like terms like this one and combine them, okay? That's totally fine. Or you can go a step further like this, okay? All right, so we've looked at today the power reducing identities, and what they do is they take a sine or a cosine or a tangent that's raised to the second power, and they rewrite it so that you have a power of 1 with a multiple angle for the angle, okay? All right.